Kuzangpo Bhutan e-learning project welcomes children to this lesson. I'm Sangye Choudhury and this lesson is chemistry lesson for Key Stage 5, classes 11 and 12. The topic for today's lesson is radioactivity and half-life. These are the objectives for today's lesson. 1. Students should be able to define radioactivity and half-life. Students should be also explaining the causes of radioactivity. Students should be able to explain the modes of decay, and students should be able to calculate half-life. Now, to tell you a brief history of how the radioactivity came into existence, it was made possible by a French scientist called Henri Becquerel. So what he did was he covered the photographic film or photographic plate with the black paper, and on top of that he kept uranium salt. So that whole setup was kept in the dark room. So later when he developed photographic plate, he could find this dark spot. Now from this conclusion he came with the point that uranium salt, which was actually kept on the black paper, this substance emitted invisible rays which got penetrated through the black paper and finally affected the photographic plate. So it was mainly due to invisible rays, or we can call it as the radiations. So radiations are of three types: alpha, beta and gamma. So later they concluded that radiations are of three types: alpha, beta and gamma. So because of this rays, it affected a lot. So from his conclusion, as of now we know that uranium salts, the element called as uranium, they are radioactive. That means they are unstable. So since they are unstable, they will now try to become stable. So to become stable, they will emit invisible rays, or called as radiation. So how does it become stable? They will emit rays. Now later, with the help of discovery made by Henri Becquerel, another scientist called Marie Curie, along with her husband, she studied about the substances which emits radioactive rays. So in that course, she discovered two new radioactive substances. So from that discovery, she again concluded that the initial element will be converted to a daughter element. Why? Because initial element, being radioactive, they are unstable. So being unstable, they will automatically emit rays and then form a new, but this time it will be stable one. So how it is achieved? By emitting alpha, beta and gamma rays. And now, the application of radioactivity, it has a lot of role to play in our human race. It means that it helps us a lot. It helped us a lot in many fields. Now, at the same time, we also need to think about the disadvantages of this phenomenon called as radioactivity. Now, what is that disadvantage? In the later part of this Marie Curie's life, she was diagnosed with the disease called as aplastic anemia, which is a blood disorder. So this blood disorder is caused by harmful radiations. So she was constantly in touch with radioactive substance. So in that phase, her body was completely exposed to this harmful radiations. So because of this harmful radiation, it affected her health, and unfortunately she passed away in the year 1934. Now to move on to the definition of radioactivity, it is the phenomenon of spontaneous emission. Now why spontaneous here? Because it is natural process. So that means it does not require the external factors to trigger the reaction. So it happens naturally. The phenomenon of spontaneous emission of certain invisible radiation by elements like uranium is called radioactivity. So what's happening? Nuclear disintegration is taking place. Why? Because the substance is unstable, because they are radioactive. The substance which emits these rays are called radioactive substances. Obviously, radioactive substance will emit rays to get stabilized. Due to radioactivity, the element changes into another element. So why it changes to another element? To become stable. How does it become stable? By emitting rays. It is spontaneous and irreversible self-integrating process. Now here irreversible, once you get the daughter nucleus from parent nucleus, then you will not be able to extract that parent nuclei or nucleus once again. Next, radioactive substances are unstable. Obviously they are unstable because they are in the process of emitting rays. They emit the rays in the form of alpha, beta particles or also in the form of gamma rays. Now we will move on to the causes of radioactivity. Number 1, even and odd number of protons and neutrons. So we have 3 categories here. First category, if the number of protons and number of neutrons are even, then the nucleus is said to be, or nuclide is said to be stable. In second category, if the number of proton is even and number of neutron is odd, then they are said to be least stable. Or else we can also say if the number of proton is odd and the number of neutron is even, then they are less stable. In the third category, if both the number of protons and number of neutrons are odd, then they are said to be least stable. So from this 3 category, these 2, less stable and least stable, they will undergo nuclear disintegration to become stable. So this is one of the causes of radioactivity, because of odd numbers of both protons and neutrons. Second cause is nuclear force. Now I'll explain this with the help of an example. So now we are with the second cause. Nuclear force. This nuclear force plays a very important role. Now what is that role? Suppose say this is nucleus. Inside the nucleus we have, it has protons and neutrons. So there are many protons as well as there are many neutrons. Now what is the function of this nuclear force? Inside the nucleus, proton, what's the nature? They are positively charged. So how is the effect between these 2 protons? The force called as repulsion will take place since it is of same charge. So because of this repulsion, now the protons will be moving apart. So when they are held apart, so sometimes we expect that this proton will move out from this nucleus or it will split the nucleus. But it doesn't happen in the stable nuclide. Why? Because of this nuclear force. This nuclear force binds the particles properly and keep inside the nucleus. So because of this force, all the particles are held tightly inside the nucleus. Now the problem with nuclear force is it is limited to certain distance. So the distance it can work is 10 to the power minus 15 meter. As far as the size of the nucleus is this much, yes, nuclear force will be very strong, holding all the particles together. So therefore, there wouldn't be any disintegration or splitting of nucleus will not take place. Now, problem comes with the heavier nuclides. Heavier nuclides, that means elements containing more number of neutrons and more number of protons. Now, what happens? For this one, the nucleus has to accommodate more number of neutrons and protons. Now, what happens to the size? Obviously, it is going to increase. Now, due to the increase in the size of nucleus, what happens to the nuclear force? It weakens. The force weakens. So, now when force gets weakened, then it will not be able to hold the particles intact. Now, because of this weak force, disintegration takes place. So, this is the second cause of radioactivity or nuclear disintegration. So, radioactivity means substance A is disintegrating into substance B by emitting alpha, beta particles and gamma rays. So, this has very important role, but the limitation is only up to certain distance, 10 to the power minus 15 meter. Once it goes beyond this, it will not be able to hold the particles together. So, when it's not able to hold the particle together, that this phase is when the disintegration takes place. Third, too many protons, too many neutrons and too many of both. This factor will cause the phenomenon called as radioactivity. Now, you can see the graph here. This graph is between number of neutrons and number of protons. So, number of neutrons is represented in y-axis and number of protons is represented in x-axis. So, you can see the number of protons represented by letter Z, or we can also write it as P. Again, you can see the graph properly in between. There are two colors, one is green and another one is blue. So, color blue represents they are non-radioactive. So, that means in that region elements will be stable. Now, once you go beyond this blue strip, you can see the green color. So, green color represents radioactive. That means the elements present in this region, they are not stable. So, they will undergo disintegration. Now, again you will see the thin straight line from this graph, black thin straight line. So, this line represents NP ratio equal to 1. NP ratio 1. So, when will we get NP ratio 1? When number of neutron is equal to number of protons. Now, let us see an example how do we get this ratio as 1. So, if we take this point here, the element present in on this line, we have 20 number of neutrons. We can see here we have 20 number of neutrons and 20 proton. So, when we find NP ratio for this element present here, NP ratio is 1. How? Because number of neutron is 20 and number of proton is also 20. So, therefore, we get 1. Now, next, this blue strip or this region under blue strip, it contains elements which are very stable. Now, if you see the region beyond this blue strip, they are said to be unstable. Elements present below this blue strip, they are also said to be unstable. And the elements residing in this region, they are also said to be unstable. Back to this blue strip, since the stable elements reside in this region, this zone is known as stability zone, or we can also call it as belt of stability. Now I told you the region above the blue strip, below the blue strip, and at the top they will undergo disintegration. So now the first one, the element present above this blue strip, what will be the aim now? They should be disintegrating to reach to this stability zone. So how this is achieved? By emitting beta particle. So the element present above the blue region here, they will undergo beta decay. So that means beta particle will be emitting. So when the beta particle gets emitted, then the element will become stable by moving near to this stability zone. Next, second one, element below this blue strip, again they are said to be unstable. So when they are unstable, so there should be one solution to go back to that stability zone. So how it is achieved? By disintegrating, by emitting positron, and with the help of process called as electron capture. Third, in this region, elements or heavier nuclides, they contain more number of protons and neutrons. So element in this region, they have too many of both. So in that case, how will they stabilize? By emitting alpha particle. Once again, above the stability zone, elements will have more number of neutrons. So the aim is to reduce the number of neutrons to go back to this stability zone. Second, the elements present below the stability zone, they will have less number of neutrons and more number of protons. So again the aim to get into this zone will be to increase the number of neutrons. So how will you increase the number of neutrons? By emitting positron, and with the help of process called as electron capture. And elements residing in this region, they will have too many of both. So they will they will emit alpha particle to get into the stability zone. To summarize this search chart or this graph, you can see here if there are too many protons. So this too many protons, it is applicable to elements present below the blue strip, So in that case, what will happen? There will be emission of positron or electron capture. Second, if there are too many neutrons, it is applicable to elements present above this stability zone. So when these elements when they have more number of neutrons, then they will emit beta particle. Next, when they have too many of both, then alpha decay will take place. That means alpha particle will be emitted. So I will explain in detail how alpha, beta and the emission of positron leads to the stabilization. So how it helps the radioactive substance to become stable with the equation. But before the explanation, you should be knowing the differences between alpha, beta and gamma. So this is known as modes of decay. Decay means disintegration here. Modes of decay. So, it is brought by number 1, alpha particle emission. Second, beta particle emission, and third, gamma rays emission. Now, we will see the difference. Alpha particle is also known as helium nuclei. Beta particle is also known as an electron. And gamma rays, they are said to be secondary emission. Now, why secondary emission unlike this two, alpha and beta particle? So, secondary emission here, gamma rays will not be emitted separately, rather it will be emitted along with the alpha and beta rays. So, when alpha and beta rays are emitted, the neutrons and protons present inside the nucleus, they will be in the excited state. So, in that excited state, gamma rays are emitted. Next, we will see the representation of alpha particle. So, since we say that it is helium nuclei, it is represented in this manner. So, this is the symbolic representation of helium atom having mass number 4 and atomic number 2. So, this is the representation of alpha particle. Now, we will move on to beta particle. So, beta particle is represented by beta or also represented by electron. So, the representation B here, it has got negligible mass. So, mass will be 0 and with the nucleus, with the charge -1. So, this is the representation of beta particle. Gamma, there is not any change. So, mass is 0, even the atomic number or the charge is 0. So, this is the representation. Now, I will explain the equation. New product formed when radioactive substance undergo alpha particle emission. So, when the radioactive substance emit alpha particle, new product formed will have mass number less by 4 units and atomic number less by 2 units. So, you will understand this concept with the help of an example. So, I will give one example. This one is radium. So, radium has atomic number 88 and with the mass number 226. Now, this is radioactive substance. When it undergoes disintegration, now we are going to emit alpha particle. So, alpha particle is represented in this manner. This is alpha particle. So, the alpha particle is emitted. Now, what is the new product here? What is the new product? So, first, before knowing the new product, we have to see the mass number. So, mass number, we said that the new product will have mass number less by 4 units. So, initially it was 226. So, here 226 minus 4. So, it will be 222. So, the new product will have mass number 222. Now, we will see the atomic number. So, how will it be? It will be less by 2 unit when the alpha particle is emitted. So, 88 minus 2, it becomes 86. So, this 86 from your periodic table, this 86 belongs to the element known as radon. So, this is disintegration process because this is radioactive isotope. So, when this radioactive isotope, radioactive isotope emits alpha particle, it will form a stable new element. So, that new element will be stable. So, how will be the product? Mass number will be less by 4 unit and atomic number less by 2 units. Now, we will see the example under beta particle emission. Here, new product formed will have same mass number as that of radioactive substance. So, there would not be any change in mass number. So, that is why I have written it as same. Now, when it comes to atomic number, it will increase by 1 unit. It will increase by 1 unit. Now, let us see an example. This is carbon isotope. So, when this carbon isotope undergoes beta particle emission, so when it emits beta particle, that means this isotope is not stable, it has to undergo disintegration. So, this isotope will emit beta particle. So, this is how the representation, this is the representation of beta particle. So, now what will be the new product? So, by seeing this concept, mass number will be 14. So, mass number will remain same. So, it same like that of carbon isotope. Now, the atomic number, it will be increasing by 1 unit. So, initially it was 6, now it becomes 7. That 7 belongs to the element known as nitrogen. So, what happens when beta particle is emitted? Mass number remains same and the atomic number increases by 1 unit. Now, gamma rays, I told you it is secondary emission and it has 0 mass and 0 charge. So, that means when gamma rays are emitted, there would not be any change in mass and atomic number. So, there would not be any formation of new product. In these two cases, there will be formation of new product, but here there will not be any formation of new product. So, from this concept, I will go back to the previous slide. Search chart. Now, from this chart known as search chart, first problem with the radioactive substance, first problem, the elements present above that stability zone, they will have more number of neutrons and less number of proton. Second radioactive substance, and the place where they reside is below the stability zone. So, they have less number of proton and less number of neutron and more number of proton. Third, they will have more number of neutron as well as more number of protons. Now, the aim is to stabilize. How will it be stabilized? Now, I'll explain with the help of an example. So, this is sodium. This sodium, before this, when the element present above the stability zone, they have more number of neutron and less number of protons. So, what will happen? Beta particle will be emitted. Now, let's see. Let's see this example. It will emit beta particle. So, this is the representation of beta particle. Now, you know the concept, when the beta particle is emitted, how will be the mass number and atomic number. So, when beta particle is emitted, the mass number will remain same as that of initial element. So, 23. Here it will increase by 1 unit, atomic number will increase by 1 unit. Now, it becomes 12, and that 12 belongs to magnesium. Now we will see how the number of neutrons has been adjusted. Previously the number of neutron was more. Now we will see in this example how it got reduced, how it gets reduced. So now this 11 is proton, and how will you find number of neutron? 23 minus 11. So how much is it? 12. Now we will see here in this case new element. What is the number of proton? 12. And number of neutron? 23 minus 12. So it will be 11. So previously the number of neutrons was 12. After emitting beta particle, number of neutrons has been decreased. Even when the number of neutron is being decreased, when you find n by p ratio here, n is 12, p is 11. So it will come around 1.09, and here n by, when you find the ratio here, n is 11 and p is 12. So it will be around 0.9. So in terms of number here, it has increased. We have achieved the aim here, and when it comes to NP ratio, what has happened? Even the NP ratio has decreased. Now after this procedure, you will see that, now suppose that this is stability zone, and in that zone, stable elements were there. So now this isotope will be here. Previously it will be here. So why it was here? Because of more number of neutrons. So to become stable, to come closer to this region, it needs to decrease the number of neutrons. So these are the ways how the neutrons are being decreased. So when the neutrons are being decreased, even the NP ratio gets decreased. So therefore the new element will now fall a little bit closer to the belt of stability, or sometimes they might get into the stability zone. So this is how the stabilization is achieved after emitting beta particle for those radioactive substances which have more number of protons. Now second one, if the radioactive substance or element contains less number of neutrons and more number of protons, how will be the stabilization? So it is brought by emitting particle known as positron. There is a difference between beta particle and positron. So positron is an electron like that of beta particle, having mass number 0, but this time the charge is +1. In the beta particle we saw it is -1. So this is positron. So this is the difference. This is positively charged, the nuclear, here it is negatively charged. But the common thing, or the property that they exhibit, the same property that they exhibit, is they have same number of mass. I mean the mass is same for both this, only the charges are different. Now we will see how the emission of positron brings about the stabilization, or how this emission of positron increases the number of neutrons. So this is magnesium. So when this element undergoes emission of positron, so positron is now represented as E, having mass number 0 and charge +1. The new formation of new product will be a little bit different from beta particle. So when the beta particle gets emitted, the new product formed will have same mass number and the atomic number will be increased by 1 unit. But for this positron, the atomic number will reduce by 1 unit and mass number will remain same. So, let us see, mass number will remain same, but the atomic number will decrease by 1 unit. So, here previously it was 12, so it will decrease by 1 unit, it becomes 11. So, 11 belongs to the element called as sodium. So, magnesium has undergone disintegration by releasing positron. So, we will again see how the number of neutrons is being adjusted here. So, here the proton is 12 and neutron will be 23 minus 12. So, it is 11. In this case, proton is 11, neutron 23 minus 11, it is 12. What is our aim in this category? To increase the number of neutrons. So, here you will see there is increase in number of neutrons. Even the NP ratio will be increased. Now, in this case, this is stability zone and the elements are residing here in this category. So, when element present here emits positron, they will move closer to this stability zone. Now, the third one, when both the number of protons and neutrons, they are too many. So, it is achieved, the stabilization is achieved by emitting alpha particle. So, we will go through the same example that we discussed earlier with the help of this radium isotope having 88 atomic number and 226. So, it emits alpha particle. So, now the product will be, when alpha particle is emitted, when the alpha particles emitted, mass number will be reduced 4 units. So, it is 222 and here 88 becomes 86 and that belongs to radon. So, this is how it is, the stabilization is brought about. So, there are three conditions. Number one, element present above the stability zone, the elements have more number of neutrons. The elements present below the stability zone, they will have less number of less number of neutrons. And in the third case, both the protons and neutrons will be too many. So, when we have too many number of neutrons and protons, then they will emit alpha particle to stabilize. In this case, they will emit positron and in this case, they will emit beta particle. Now, in the previous slide, you also saw, apart from this positron, process called as electron capture will take place. Now, what does this electron capture? So, even this process called electron capture will help to stabilize the radioactive element. Now, what is electron capture? So, in this case, the nucleus, the element will capture the orbiting electron. So, I will take the same example, magnesium 1223. Instead of, now we can, in this case, we can see the beta particle and positron in the product side. But in this case, since it is electron capture, it will be in the reactant side. So, it is the same representation, E having mass number 0 and charge minus 1. So, what happens? This magnesium will absorb or capture the orbiting electron. So, we will see the product. So, what will be the product? Mass number will be 23 when we combine this two, and here you will see 12 minus 1, it becomes 11. So, this 11 belongs to sodium. So, in this case, two particles will be emitted, number one positron and with the help of electron capture. So, again we will see the number of neutrons, how it is being increased. So, here 23 minus 12, 11, 23 minus 11, is 12. So the number of neutron is being increased. So in this case, two concepts, the two properties or two particles to help the radioactive substance to stabilize. So this is it for the third cause. Next, we will see half-life. So the definition of this half-life is amount of time taken or amount of time it takes for half of a radioactive sample to disintegrate. Or you can also say half-life is the time taken by any radioactive substance to disintegrate half of its concentration. So I will explain with the help of the graph here. You can see the first diagram here. This is radioactive substance. So what is that radioactive substance? Cobalt 60. Now second one, you can see here 50% of this initial 50% of the initial concentration. Initially it was 100%. Now only 50% has retained. Now what has happened to this 50% above, present above this substance? It has disintegrated and formed a new product. So what is the time taken for this substance to disintegrate to half of its concentration? So what is the half-life? So it is 5.3 years. So in that many years, this radioactive substance will disintegrate into half of its concentration. In second graph, in the second picture, you can see 50% is retained. Again, the reaction will not stop here. The initial concentration is 50 and the half of this 50 is 25. Again, it will take same number of years, 5.3 years to reduce to its half. Another same concept, 25%, half of this concentration is 12.5. It takes another 5.3 years to reach to this concentration. So it goes on and on until all the radioactive substance is disintegrated and forms a new stable element. That new stable element is known as daughter nuclei, and the first picture, it represents parent material. So what is half-life? It is the time taken by radioactive substance to disintegrate to half of its concentration. From 100 it becomes 50, from 50 it becomes 25. So what is the time taken in that process to reduce half of its concentration? So they found out that in the first, the half-life was 5.3 years. So in that similar manner they will follow that. Since the half-life is 5.3 years, so the other substance will take that same number of years to reduce to half of its concentration. So this is the concept of half-life. Now we will see simple calculation based on half-life. So I will give formula here. I will give the formula. N is equal to n naught 1 by 2 raised to the power n. So I will introduce each of the parameters here. This n is the amount of substance left after disintegration. So this is final amount. You can see n naught. So this one is initial concentration before undergoing disintegration, and this is initial amount. And what is this n here, small letter n? This is number of half-life. Again, you have the formula to calculate number of half-life. This is the formula. N is equal to T by T half. So what is T? It is time, and this T half is half-life. Now based on this formula, we will see an example, we will solve a numerical problem. So this is the question. calculate the amount of iodine isotope left after 180 days when 4 gram of radioisotope was taken initially. So, first information that it gives is amount of calculate the amount of iodine isotope left. So, what you have to calculate? Amount of the substance left. So, this is denoted by letter N. So, this is question mark since you are asked to find this. Next, after 180 days. So, what is that 180 days? It is time. When 4 gram of radioisotope was taken initially. So, from the sentence itself you will understand what is that 4 grams. So, this is initial concentration. So, this initial concentration is represented by N naught, 4 gram. T half is given 60 days. So, we have all the information, we just need to substitute in the formula. So, this is the formula, N is equal to N naught 1 by 2 raised to power N. Now, before solving this equation, before substituting in this equation, we have to find N. So, what is N? T divided by T half. So, T we have 180 days and T half it is 60 days. So, when we calculate we get 3. Now, we will substitute in this formula. So, N is 4 and N naught, N you have to find, N naught is 4 and N becomes 3. So, what will be the answer? N is equal to 0.5 gram. So, that means this much amount is left after the disintegration. We have come to an end, but before this I have got few questions. Number 1. In what different ways are we exposed to radiations in our day-to-day life? So, every day our body is exposed to different radiation, but we are not aware of. So, I want you to do a little bit of research here and then write what different ways are we exposed to radiations and also disadvantages and advantages. Next. Explain radioactivity with the help of a search chart. So, it will help you revise again. So, explain that chart. Differentiate alpha, beta and gamma rays based on their penetrating power. Last one is related to half-life. So, half-life of polonium is 140 days. So, T half is given. Find the mass of polonium left. So, that means you have to find N here after 5 days. So, what is 5 days? Is time taken, is time, and if 16 gram was taken initially, so that 16 gram becomes initial concentration. You have to find final concentration and other two informations are given. So, half-life is given and T is given. So, please submit it to your respective subject teachers. So, with this I have come to an end. Thank you students for attending this lesson.